Okay, so fast forward a few days, I was working on a save system so that in turn I could make a loading system as well and then start working on multiplayer. So right now, this is empty. If I press F6, it's gonna save. And it's quite slow right now. It requires a second to do all of that because it's creating a bunch of text files. I might optimize that in the end. The bottleneck are basically tiles because they're individual objects, and I'm storing each one of them into their own separate text file. I might change that in the future, but we'll see. For now, it kind of works. So in the game we have 3 world containers, as you can see here, which all contain one world. So right now we have 3 worlds like that, and only the first one actually has an entity associated, and you can see that's the case here. So in the world container we have world container data, which tells us everything we need to know about this particular world container, and then the world which is contained within it also has some data associated with it. And then you have chunks, which then contain a little bit of data for themselves, and they have references to tile objects, and then you have the individual tile objects. Now this is the bottleneck. I should not be creating this many text files. Ideally, I would compress these into a single file called tiles something, and I would read from that. But this is how I have it set up for now, and it seems to do the job. I'll think about optimizing it in the future. I just wanted to show it off real quick. I actually managed to bring down the save time drastically. I just need to, I didn't prepare. Every time I start to record, I have not prepared a single thing. Okay, deleting all the data, pressing F6. Game is saved in 0.01 seconds, which is like 100 times, not quite 100 times, but more than 50 times faster than it used to be. And the main optimization we're doing is we're not saving the tiles directly anymore. Like, remember, you used to have a big sort of reference for tiles in here that says, hey, this tile is at this position, and then we had a folder with all the tiles. Now we just saved the tile buffer, which sort of saves just a fraction of the data needed to recreate the tiles, but I'm hoping I can save just enough data to be able to recreate the world. So the next, to start working on loading this data in. But before that, I actually want to try just to see how long it would take for it to save this planet. Okay. So we just had these 3 worlds to work with, but now we're actually gonna attempt to save this whole planet. And so I'm gonna press F6, and it does it in 1/4 of a second. So it's pretty good. Not really as elegant as saving the individual tile objects and then just recalling them later. But we will have to do some manual work with loading. So I've done a bunch more progress last night, and I refined the save function that I had before. And what I used to have is a big conglomeration of code that basically I re-implemented this function. And the reason I didn't use it at the start, because I couldn't wrap my head around how it worked, or to be specific, how this filter function worked. And so what I was always confused about, whenever I try to use it, I would get usually an empty struct. And there's a reason for that, is because I didn't know that on the first iteration, when you call this function, it actually processes the whole struct you pass in as a key value pair. So you get an empty key on the first iteration, and the whole struct you initially pass in as the value argument. And what was usually happening, I was checking if it's an instance of game objects, because I'm trying to get rid of including nesting game objects within game objects, I'm trying to save them separately in separate files. So what I'm usually checking is if value is an instance of game object, I'm usually just giving it a random name and not passing the actual struct. And essentially what happened, since it was the first iteration and I didn't know it processed the whole initial struct, and usually what you're trying to save is a game object, it would immediately just return this and not even process the rest of the rest of the struct. So that was one thing. And there's another quirk with it, is that it saves static members as well, which is something I don't want. So I basically make a copy of the struct we're processing and just loop through the struct names and set them like that. And what that also allows me is to make a little blacklist for members that I don't want to include into the save file. For example, let's see, we don't want to include behavior because that's pretty much a static thing, and like the lookup tables and stuff like that. And there's probably more things that I don't want saved. Yeah, like the tile, three-dimensional tile array, because we're saving the tile buffer instead. So we don't need this, it's just redundant. Okay, so it works nicely. So definitely I have to start working on the loading of this and try to actually use this data to load a game state. And that's the next big step before I try to do anything to do with multiplayer. So yeah, we got a lot of work to do. Okay, so here's a look into the loading function. Now, the only difference between last time and this time is that we're also saving some game data, as you can see here, to help us recreate the world state as it was. And there's a few different steps here. So we call this load function, and it takes a starting directory. And so we delete game data we recreated, and then we start loading. We basically start scanning this directory and just seeing what comes up. And then if we bump into a game object which contain this hashtag in the file name, so that's how we figure that out. It basically loads the data and then processes it. So it loads game object, which is the next function here. So we load game object, blah blah blah. We construct the object, we read the JSON, we merge that JSON into the constructed object, and then we add some references here so that we can fix references in our objects. Because remember, the way we save these objects, game objects, before, is basically a simplified version of what it is in the game. And for example, this world container we have an array of worlds in there, and usually how the actual data in GameMaker looks is there's an actual like struct here with all kinds of data, and that struct typically has a reference to this struct, and so you get this infinite loop. And so we don't want that, so instead we put just references of objects in our files, like so. And so what needs to happen when we load the game, we need to restore these references correctly so that our game functions the way it was. So we basically save all these objects into a DS map. I might replace this with a normal struct. Maybe that will help us with optimization a little bit, because I feel like DS maps are slow. There might be the same. I'm going to try both and see which one is better. But for now, we just have a DS map with all the objects and some sort of basically a code or a key that lets us know that that's that object. And then we basically do that, and then we regenerate references for each of the objects. So we basically just replace these with the actual proper structs in the game, and so that everything works the way it's supposed to. So quick little demonstration. And there we are. It's loaded. You probably didn't even notice that, but no, we're not actually. This is not pre-created a pre-created level. This is actually loading in a game state from this folder here. If I comment this out, you'll see that we get a blank screen. So saving loading works. So next up is going to be a basic form of multiplayer. So I do want a server and a client, and us to be able to connect to the game and control our character and not other people's characters. So that's going to be a fun challenge to do next. Okay, so I have a very simple version of the server up and running, and I'll show you what it is real quick. So this is the object that we used to work with this whole time, object game, which is basically our server and client all in one. And there's a whole bunch of stuff here. It's running the step events, it's drawing the world. We have some debug stuff over here as well. So I've stripped all of this down and I've created a server object. It is a stripped down version of our previous object. So we just initialize what's needed. There's some profiling stuff, which I'm not using at the moment, but I will as soon as I set it up. And it basically loads our game. And then I'm setting up a time source. So the server is running basically at 10 frames a second. So in practice, it kind of looks like... So this is our normal. This is how we had things before. This is our server and client together. And then if I press F10, it's going to launch a server. It's going to load its copy of the world. There's no server-client communication yet. The server is basically just loading its separate copy of the world save. And so if I switch, as you can see, its server is going to be running a very choppy version of the game, and the client is basically going to smooth that out for us. And as you can see, if I server side, if I kill these docking gates and I switch back, you can see that it's a completely different copy of the world. Now, the next step will be to set up some sort of a client-server communication protocol. Hi there, so this is quite a bit later. I've actually finished up all the bugs, got that all polished out and stuff like that, and I've started working on a simple client-server situation. And by the way, I've started using GitHub or Git. And I've just been kind of getting a hang of this, and it's really nice. It's really not that difficult. I thought it was gonna be super hard to understand, but it actually isn't all that bad. Basically, we are on a we're not on the main branch at the moment. We're on a separate branch networking because I wasn't really sure if this method is going to work, but it actually seems to be working fine. So I might actually merge this into the main branch pretty soon. Anyways, what we have going on so far is how do we do it? I haven't actually been working on this for a couple of days now. I think it's F10. Yes, it's F10. Okay, and so now we generate a world, and this is, by the way, this is client side. We're running a server and we're running a client which connected to that server and is receiving data and updates. And this is the server side, as you can see. This guy's gonna choose a random spot to walk to in a second, hopefully. Yes, okay, so the server is running at 10 FPS, and our client is interpolating to whatever my monitor is running at. It's a bit jagged at the moment, and you know, some stuff like block updates, I still don't have that in the game, so I can build separately on the client and the server, and those changes you can see will not get correctly updated for both of these. But you know, I got the basics down, and that's kind of what I wanted. So I did a little bit of fail-safe thingy for the client. So imagine if you have a situation, you're running a server, and now we have a server and a client side, and the client just decides to, like, okay, let's delete the world. What would happen is the client would still be receiving messages for, let's say this entity here for the step update. And what it's going to look at, it's going to look at the entity ID. It's going to read that from the buffer, and it's going to say, imagine this doesn't exist, by the way. None of this. That's the failsafe I've just added. So it reads the entity ID, and it's going to go directly into the entity lookup table. It's going to read that, spit out an entity, and try to do operations on that entity. Not really, checking if this is a valid entity, or if maybe this index is outside of the scope of this array. So now we have basically this, but the problem I faced here is, okay, yeah, we can't just return out of this because there's still data in this buffer. And so the next time the client tries to read a server message, it's going to start from the wrong place because we haven't actually finished off the buffer. Because the way I'm doing server messages is that I'm basically compiling multiple messages into a single network packet. So, for example, one buffer, it might contain multiple messages. This is kind of how I'm handling it. I'm checking if we've reached the end of the message, and if we have, we break out. But if we haven't, we try to decode that message. So if we hadn't finished off reading the whole message, it's going to try to read the next message, which is going to have the completely wrong key, and it might just crash the game or something like that. So to handle that, I'm writing a U32 for the just message ID. And then I'm saving where the start of the message is. And I'm just reserving 32 bits for the message size, which I write at the end here. So I just record the final seek. I get the message size, which is the difference between the final seek and the seek that we recorded over here. -4, because we still have to write the message size, right? And we seek to the start, we write the message size at the beginning over here, and then we seek back to the end. And then we send that message, right? And so what the client does now is when it receives the message here, it actually reads that size immediately after the message key. And we calculate, it calculates where it needs to skip the message if the message turns out to be invalid or for some reason. For example, in this case, for the entity step update, when there's an error happening, for example, we're trying to look outside of the scope of the array, it's going to print out an error, trying to access entity ID outside of range of the array, and it's going to seek the buffer to the final seek for the message. So it basically is going to skip the whole message, and so whichever message comes directly after this one, it's going to read it properly. Now that I've actually done a little bit of fail-safing, so we can run our game again here. I can show you what it does. I don't have block updates in the game. So for example, if I build over here, I already showed this, but if I build on the client side, the server has no clue that it happened. And so what I do now is basically in the server, if I press F2, I'm just sending a full update again for the whole world. And we append the message to all of the clients. So it's just a global update basically. And if we do this now, you can see that the client now gets the correct world shape. This is the long way of doing it, obviously. You don't want to be sending data about the entire universe every time the block changes, but it's just a proof of concept that in case something goes wrong, the client can request, hey, give me a full update, something went wrong here, and then the server can be like, okay, I'm sending you a full update. Yeah, so the client receives the full update, and it spits out an error. World container ID 0 already exists, so it's going to delete it and reinstantiate it. So it's basically going to wipe the data for that whole world container and recreate it with the new data. And as a final networking update, I want to just show that we have block updates in the game. And now I'm looking at the client side, and you can see if I build on the client side, we get the changes on the server side. If I delete a block from the server, the client gets the update as well. And then a client can build, for example, this block. That all works. The only thing that's kind of broken at the moment, and I have to fix it, is when we create these docking gates, client side doesn't look right because the final block we put only got the correct state. Still don't have an ability to change multiple blocks at the same time. That's something we still have to do. But so this is the point where I kind of feel I feel comfortable merging this branch into the main, because I feel like I've done a good job. All of this works well enough to where I think it's not going to hinder me, and so that's kind of what I'm gonna do. I'm still learning GitHub, so I just watched the quick tutorial, and as far as I'm aware, what you need to do, I'm not gonna save any changes there. What you need to do is you go to main branch, and then you go here and merge into current branch networking. And there we are. I guess I need to delete it after I merge. I'm not sure. I haven't done this before. Yeah, everything looks fine. We still have all the networking code in here. And just let me run the game once to see that everything seems to be working the same way. Yeah, that looks good. Okay, cool. Successfully merged. So now I'm assuming we can just delete this, right? Right? Yeah. That looks good. We still have all the stuff here. Okay. Yeah, cool. Okay. Yeah, GitHub is or Git in general is cool. I like it. Nice. There we are. So now we have networking in our game, and I'll keep working on this as I'm working on like other features in the game. All right, cool.